Hello everyone, this is Lukman. I'm going to take you through to my AI project as I made a first video about my project, basically the idea. So my project is about avoiding wasting time and contamination diseases using fingerprints in private administration. We are going to use finger we are going to use face recognition replacing by fingerprint. So by solving this problem, we are going to use cargo dataset. How we are going to use it? In this kind of system, as we are working as administration staff, so we are going to take pictures for different administrators such as that to train our system. Like, we are going to take their pictures to train the system and store them in our database, that whenever those people they go to the system can be able to capture their face and give them access to lock and unlock the system. Yeah. And then we are going to use also some pictures to train the system. That's and there we are going to use like the method of unsupervised learning, as we introduced before. Going to take some pictures to train our system, like the system can be able to capture such kind of faces as possible, as soon as possible. Yeah. So let's proceed to the next slide. In this slide, we are going to explain to you our our four data set factors we are going to use to solve this kind of problem. First of all, you are going to use security. As you know, security in this case, we are going to secure our system, our data, that the outsider cannot be interrupted them. We are going to avoid here we are going to basically we are going to avoid theft or loss of that data. Yeah. Then we are going to use functionality. Basically, functionality, we have to make sure that our system is going to, I can say, behave like, maybe we are going to our system we are going to train it or to make it to work as such system that people have made them. Like, we're not going to make like our system is different from others. Yeah. Then next, I want to see the integration. Basically here basically here we are going to considering, does the system integrate with our current system we are to work on. Like, maybe here we are going to make sure that our system is going to, no. Let me go to the next slide. You see, scalability. Here, we are going to make our system to ensure that the capacity of our system to grow, or maybe we can be able to make our system to get more interested to more customers. Yeah, basically that is it. So here we are going to talk about the 5 important features data sets we are going to use solving this real problem. Further, we are going to use storage. In this case, we have to make sure that our system or our data set can be able to hold our data. We are going to use it. Then open source, we have open source, have supported file types and tag pages and notebook output, file data set. Yeah, we are going to use all those kind of data set to make sure that our system is going to be considered. Then next slide, I'm going to explain to you more about Bayesian theorem. When we are talking about Bayesian theorem, it is basically a mathematical formula to determine the condition of probability of given probability. Like, for example, if you have given a probability of a given probability b, to solve such problem, we are going to take the condition of probability a given b times a over b to solve such kind of problem in mathematics. But in AI, in real world, the Bayesian reasoning help the help the software developers, or help the knowledge of provide a way to upload probabilities given new. Yeah, something like that. Then next, we are going to explain about Bayesian network. When we are talking about Bayesian network, that is a network type of probabilistic graphic model that can be used to build a data and expert opinion. How? Here, it's kinda similar to Bayesian theorem, but here we are going to use graphical models to come up with to solve our problem. We are going to talk tasks including prediction, such thing like that, etc. etc. In real world, we use this Bayesian network to define the node and the variable and links. Also use the law probability, or such as addition or multiplication and complements. Yeah, we use such law to come up with our Bayesian network. Then next, I'm going to take you through to naive Bayes. As you hear the name of naive, it's a simple learning algorithm that utilize Bayes together. Here in naive, we are going to use the Bayes within it. Naive is such a strong assumption that the attribute unconditionally independent given the class. How? The computational efficiency features lead to the naive Bayes being widely applied in practice. Yeah, that's how we know continuous of naive. For example, when for example, we have probability of A given B of each class A given and object B. It is probabilistic classify, which means it is predict on the basis of the probability on object. Yeah. So I'm going to take you through the difference between Bayesian theorem and naive Bayes. Bayesian theorem assume no conditional independence. In Bayesian theorem, there is no conditional independence, whereas naive has conditional independence given. Yeah, such as we can find P probability of A given C or probability of A given B given C, such kind of things. And in naive, in Bayesian theorem is kind of slow, whereas naive is totally faster. Yeah. Let's proceed to difference between naive Bayes and Bayesian network. Naive Bayes, here all the features and conditionally are independent of each other, whereas Bayesian networks, as earlier said, that it is dependence, not independence. But naive Bayes, the conditional probability, it is independence. Yeah. And here we also know that naive is simple due assumption made. It is very simple to come up with. Whereas Bayesian network, we have to use graphical model that present a set of variable and their conditional dependencies. Yeah, that is the difference of between both of them. Yeah. So I'm going to take you through to the next slide. It's about the references. You can see to my screen references Bremen Leo, Search BTBT, Artificial Intelligence. Those are the references that you can search and come up with the thingy. So as that time has run out, so allow me to stop there. So thank you for listening and thank you for subscribing.